Hi everyone, and welcome back to another science experiment. I'm Michaela from Superior Science, and today we're doing an experiment dealing with physics and engineering. The experiment today is called bottle cars. Alright, so in our experiment today, we're going to be looking at conservation of energy, kinetic and potential energy, and Newton's third law of motion. Let's get started with some questions. Who here has ever blown up a balloon and let it go? What happens when a balloon full of air is released? And why does a full balloon move like that after it's released? To start answering some of these questions, we're going to look at some background information. It might not seem like it at first, but a simple balloon car is loaded with physics and engineering concepts. When you inflate a balloon, it stores potential energy in the form of stretched rubber and compressed air inside. When you release the balloon, its energy is converted to kinetic energy, the energy of motion. As the balloon zooms around the room, some of the energy is also converted to heat due to friction. So what is kinetic energy? As I mentioned earlier, kinetic energy is the energy of motion. What is potential energy? Potential energy is the energy of an object relative to its surroundings. According to the law of conservation of energy, the total amount of energy is conserved. Energy never disappears, it just changes to another form. Let's imagine a large hill with a ball at the top. The ball at the top of the hill contains gravitational potential energy as it's elevated from the ground. Once it rolls down the hill, that energy is converted to kinetic energy. Newton has 3 laws of motion. Inertia states that objects in motion will remain in motion. Force is equal to mass times acceleration, and for every action, there's an equal and opposite reaction, which is the one we're focusing on today. You may be sitting there asking yourself, who is Isaac Newton? During his lifetime, he developed the theory of gravity, the laws of motion, and a new type of mathematics called calculus. Legend has it that a young Newton was sitting under an apple tree when he was bonked in the head by a falling piece of fruit. This prompted him to suddenly come up with his laws of gravity. As previously mentioned, Newton's third law of motion states that for every action there's an equal and opposite reaction. In this example, the action force is the person dismounting the boat to the left. The reaction force is the boat moving to the right. Try this. Push your hand as hard as you can into the wall. It doesn't break the wall. Why? Because the wall exerts an equal and opposite force on your hand. Now let's think about our experiment today. When you inflate a balloon and then release the nozzle, the rubber contracts and pushes the air out the nozzle. This means that there must be an equal and opposite reaction. The air pushes back on the rubber, propelling the balloon forward. This principle is used in real rockets and jets that shoot a high-speed stream of gas out the back of their engines, propelling the vehicle forward. The car also contains a simple machine, the wheel and axle. This invention has been around for so long we take it for granted, and many of us ride in wheeled vehicles every day. Now on to materials. For today's experiment, we need a plastic bottle, 4 plastic bottle caps, a wooden skewer, 2 straws, a balloon, tape, and scissors. Now take your wooden skewer, find the center, and cut it in half. I scored mine with scissors and then broke it in 2. Push each of the skewer pieces through its own straw already attached to the bottle. This will form the axle. Use scissors to poke a plus-shaped hole directly in the center of each plastic bottle cap. Get an adult's help or supervision at this point. Press each bottle cap onto the ends of the wooden skewers to form wheels. Put your car down on a flat surface and give it a good push. If the car doesn't run smoothly, make sure your axles are parallel, the holes in each bottle cap are centered, and the straws are securely taped. Tape the neck of the balloon around one end of the other straw. Wrap the tape very tightly so the connection is airtight. Make sure you put the balloon on the end past the bend that is shorter on your straw. Next, cut a small hole in the top of the water bottle, just big enough to push the straw through. Push the free end of the straw through the hole and out the mouth of the bottle. Use tape to secure the straw as needed. Now you can blow through the straw to inflate the balloon. Then put your finger over the tip of the straw to trap the air. What do you think will happen when you put your car down and release your finger?